Okay, so now that we've seen an overview of the spine setup that we will be creating, in this video I want to create our spine curve and then create some bones from that curve and deal with setting up stretchy spline on those bones and also how we can lock the stretchiness of those bones so that if we set a parameter to a locked value, then we don't have stretchy bones, and if we set that to a stretchy value, then we do have stretchiness on those bones, just in the same way as our legs and our arms back from character rigging 1 were set up to allow stretchiness or disable stretchiness. So let's jump over into Houdini, and I'm going to start out in a side view creating a curve for the spine. Now to do that I want to turn off the visibility of everything that's nulls so that we can see our geometry. I'm also going to turn off the visibility of bones so that we're only dealing with our geometry. I also want to bring up the visibility of the skeleton so that we can see both the spine of the skeleton and also the geometry rather of our goblin character. So I'm going to start this off down by the hips, run a curve through the spine, and then I'm going to finish that curve up here around the arms, around the shoulders. Now it's worth noting I want to keep the number of points that I create on this curve to a specific number that I have in mind. I want to create a curve that has 6 CVs. That's because we know that we're going to have one control created for each of those CVs when we set this up as a stretchy spline. Now I know that the very first CV, CV0, is going to be attached to our hips. I know that the last 2 CVs, 4 and 5, I want attached to our shoulder control when we create it. That means that I'm in between that going to have CV1, CV2 and CV3 that have our manual controls, thus matching over on the whiteboard where we said we're going to have 3 controls for the manual control of that spine curve. So let's go ahead and create that curve. I'm going to create a curve. I want a nerves curve. Now I do want to go ahead and show all other objects so that we can see our geometry while we're creating that curve. And let's start out down here at the hips and work our way up the spine, creating a curve that has 6 CVs. Now the 4th and 5th CV numbers, so CVs 5 and 6, are actually going to be very tightly spaced up in the shoulders. The reason for that is when we move our shoulder control and when we rotate our shoulder control, I want the end of the curve to come into the shoulder control at a specific angle, giving us a little bit of control over the final orientation of that final bone. So let's go ahead. We've created 2 CVs. I want to create a 3rd, a 4th, and then 5 and 6 are going to be spaced fairly closely up here. So 5 and 6 right around our shoulders. Enter to accept that. Our curve is following the spine fairly closely. Let's go ahead and bring that back in slightly. Bring that back in slightly. Something like that's working nicely. I will go ahead, turn off our goblin geometry, turn off our skeleton geometry. And that's working very nicely. That is following the curvature of our skeleton spine, and since we do want to hook our skeleton up to the bones that will be generated from this curve at a later point, even though we're not going to do that on DVD, on camera, it is something the intention for the rig, obviously, for the bones to be hooked up. It makes sense to make sure those bones, when they're created, are going to lie inside that geometry. So we've got that curve in place. I'm going to rename it to spine curve. I'm going to deselect the curve, and I want to create bones from this curve. Now to do that, I'm actually going to jump into the front view with space 3. And this is kind of interesting. I want to create bones that have their rotate X, the X-axis of their rotations, of their orientations, facing out to the sides, since that's the major rotations for our spine. When using the create bones from curve tool in this way, that actually means we need to be in the front view to get that working. So I'm going to create bones from curve. I still have follow kinematics set from earlier. I do indeed want to keep follow kinematics set. This chain is going to be our spine, and the number of bones I want to create is 5. I only want 5 bones because I'm setting this rig up to generate a rig that can be used for both our goblin geometry and our skeleton. And whereas with our skeleton we have a number of distinct pieces that, yes, if we had 1 bone per piece we would get more subtle motions in the spine. If we had that many different bones when we're trying to hook our goblin geometry up to the spine, it would be a nightmare to paint our weights. So instead what I'm going to do, I'm going to set this up with 5 bones, and then if you were to want to attach the skeleton to those bones, you could simply group certain pieces of the spine for the skeleton and parent them all to a single bone, and actually the deformations you get off that look almost as good as if you had a number of bones. You'd actually never really notice that they were all grouped together, except for in the most extreme of poses. So I'm only going to create 5 bones, and with our spine curve selected, I'm going to go ahead, push enter. That's going to create 5 bones for our spine. If we jump over into a perspective view, let's hide the skeleton geometry and bring back visibility of our nulls and bring back visibility of our bones. We can see that they are indeed oriented with rotate X facing out to the side. So we've got our bones there. Let's go ahead and set up our bones so the spine root will turn off visibility and selectability, and the spine bones, let's grab all of these guys, turn off selectability and give them an orangey yellow node color. We can go ahead and move these up towards the center of our rig. So I'm going to move them above the hip control that we created. And since our spine is actually running up the character, I'm going to reverse the order of these nodes. So we'll start out with our spine root and start placing these bones going up as their number increases, as opposed to down the network as their number increases, keeping with the idea of having our nodes in the network roughly map out the character that we're creating. I'm also going to turn off visibility and selectability of the curve used to create those bones. So now that we've got that in place, we can apply stretchy spline to those bones. We can apply that stretchy spline tool. So I'm going to activate the stretchy spline tool, and I had to grab any bone in the IK hierarchy, so I'll just grab one of our bones that we created and push enter to confirm. That will set them up to be on a stretchy spline, which means we can come in and grab control objects, and that will move our bones. Now I want to undo and make sure that I don't move these from their default locations to begin with. So the first thing I'm going to do in terms of our stretchy spline is I'm going to take Control 0, and if we maximize our network editor for a second, you can see that spine bone 1 is parented into Control 0, and then Control 0 is parented into our root. Instead of having that parented into our root, I'm going to parent it into our hip control, and then I'm going to delete out our root. So I do want to make sure we keep position when parenting. I'm going to parent that into our hip control. I'm then going to delete out our root. You'll notice that all of our other controls do maintain their position even though they were parented to the root. Let's grab that spine curve, Control 0, turn off its visibility and selectability, and change its node color back down to a gray, since it isn't a control object anymore. And then we can go ahead, we can grab our hip control, and if we grab our hip control and were to move this, that's now going to be affecting the bottom of our spine. Fantastic. So let's go ahead and temporarily parent in the rest of our control objects to the hip control. The reason I want to do that is to show an issue that we have currently when we use the uniform scale on our master control with our current setup. So I'm going to go ahead and grab all of our controls for the spine. I'm going to parent them whilst keeping position into our hip control, and this is just temporary. That means now, since the hip control itself is parented into the master control, it's going to inherit the master control's transformations. If we uniform scale the master control, we uniform scale the hip, and our control objects will move from that. Now we're going to see an issue when we do this. It's probably going to be more evident when we scale down than scale up. But notice, when we scale up, notice how our control objects are moving, and that should really be where our bones are, but notice our bones getting longer and longer as well. In actual fact, our bones are getting scaled twice, and I'll explain why in a second. We can see when we scale down as well, maybe not quite that extreme, we can see when we scale down that our bones are getting scaled down twice compared to the rest of our rig. Now the reason this is occurring, our bones are parented in to the master control. So when we're scaling our master control, we're scaling our bones. But our controls as well for that curve are parented into the master control. So when we scale our master control, those controls are getting repositioned. When the controls get repositioned, they are changing the length of our curve. When the length of our curve gets changed, that curve length that's being referenced to drive the length of our bones is causing the bones to be shrunk down yet again. We need to make sure that the curve length itself is unaffected by our uniform scale, so we can jump in and we can change the expression that's being used to drive our curve length, and we can jump in and we can make sure that if we divide that by our uniform scale as we scale up, even though that curve length is increasing, it's going to then be scaled back down by the fact that we're dividing by our uniform scale. Or if we scale down, even though our curve length is decreasing, that's going to be increased back up by the fact that we're dividing by a number less than 1. So I want to jump inside our spine curve, and on the for length calculations null created by our stretchy spline tool, the length of curve expression, I'm going to change from being the arc length of that curve to now being the arc length of the curve divided by, we want to jump up and grab the master control. We want to grab his scale parameter, that is the uniform scale parameter. So if we accept this and were to scale now uniformly our master control, you'll notice that the length of the curve will be affected by our control objects, but then the length of the curve is going to be divided back down by the uniform scale. That means that our bones technically are too short, but because our bones are also getting scaled up by the fact that they're parented into the master control, that now brings them back up to the correct length. And since our curve is itself being modified, it's just the length of the curve that we're referencing that isn't being modified, that curve itself is still sitting perfectly for our inverse kinematics that are being driven for our bones, so that our bones follow that curve. So you notice the curve is still sitting there perfectly because the control objects affecting it are moving. So now that we have that in place, we are indeed able to uniformly scale our rig, and our spine will scale with the master control successfully. I do want to get our lock in place for locking and unlocking the stretchiness of our spine. I'm going to add that as a parameter on our master control. So I'm going to right click on the master control, come up to edit parameter interface. I'm going to create a new float just right up here at the top of our parameters, and I'm going to name this to spine lock with a label of spine stretchiness. Now, in the exact same way that we had those stretchy locks back in character rigging 1, we're going to have this such that a value of 0 means that we don't have any stretchiness, and a value of 1 means that we do have stretchiness, and we're going to lock this between a range of 0 and 1. So I'm going to lock that with a minimum of 0 and a maximum of 1, so we can accept that. Now we need to make sure that our bone lengths obey that parameter. That means when we have that parameter set to 0, our bone should be at its initial length and not be stretched based on our stretchy spine setup. However, when we have a value of 1 on that spine stretchiness, then we want to inherit the full stretchiness coming from our stretchy spine setup. So to do that, I'm going to linearly interpolate based on that spine stretchiness being our parameter we're interpolating on. I'm going to linearly interpolate between our eye length, our original length of the bone, that is a parameter we'll need to add to one of our bones, and the stretched length of our bone. It's worth noting that all of our bones always share the same length. We have actually taken the total length of the curve and divided it by the number of bones. That means that we're always going to have the same length of bone. That means I can only need to calculate the length of the bone for one of these bones in the spine. I'll do it on the first bone and then reference that bone length on all of the other bones in our spine. So on the first spine bone, on spine underscore bone 1, I'm going to go ahead and grab his bone length parameter, and let's bring that up in an expression editor. Because currently we're taking the number of bones, we're taking the length of our curve, and we're dividing the length of the curve by the number of bones. That's giving us the length for this particular bone. That's great. That's what we need when we want full stretchiness. And if that's what we need when we want full stretchiness, that means we want to go ahead and multiply this in by that spine lock, so that when spine lock has a value of 1, we get 100% of this. When it has a value of 0, we get none of this. So I want to grab our master control and grab that spine lock parameter and multiply that in by our spine's for length calculations length, and dividing that by the number of bones. If we accept that, that first bone is going to collapse because currently we are set to a value of 0 on the spine lock. We can jump back down to our master control, and if we start increasing that, you'll see that we now go from our stretched length, but we collapse down to 0. That's because we need to know about our original length and include that in our linear interpolation expression. So I'm going to right click on spine bone 1 and edit its parameter interface. I'm going to create a new floating parameter just underneath the bone length parameter, and I'm going to name this to iLength. I'm going to give that the label of i.length. This is going to be our initial length of the bone. Now, if I jump back down to our master control, and I was to set that spine lock up to a value of 1, that means that I'm going to take the length as it is now, and I'm going to use that as our initial length. I'm going to say this is the rest pose of our character, and this is the initial length. That means I can jump over to the bone and get a value for the current bone length, copy that with Control-C, paste that into our eye length, and that length is going to now be our initial length for this bone. I can now jump in and bring up the expression editor on our bone length expression. So we've got the second part of our linear interpolation that deals with when we want to be set to a value of 1 on our spine lock and we want to have that stretched length. We need to create the first part of our linear interpolation expression. So we're going to use 1 minus our master control spine lock, since of course we want to have this with a value of 1 when spine lock is equal to 0 and a value of 0 when spine lock is equal to 1, and I want to multiply that in by our newly created iLength parameter. We can take the result of that, if we add it in to the existing expression, that's going to give us that linear interpolation where we have 1 minus t, that's t our parameter, 1 minus t times one number plus t times our second number. As t goes from 0 to 1, we go from our first number over to our second number. The exact same linear interpolation that we saw time and time again over in character rigging 1. So I'm going to accept that expression. And that means now, if I was to take a look down on our master control and set this to a spine stretchiness of 0, instead of collapsing to nothing, we maintain that initial length. As we blend back and forwards, at the moment we have no change because our length isn't changing. However, if I was to grab our hips and move our hips down, and our controls are actually still parented into the hips, so let's rectify that right now. So let's grab all of the controls except for control 0. I want to unparent them from the hips. It's also worth noting while we're here, for those of you who weren't with us for the technical rigging series and don't know the inner workings of the stretchy spline tool, these control objects that were created by the stretchy spline tool need to have their names left in the exact same way that they was when they were created for that tool to work. It uses a clever naming convention, working with CV numbers and the numbers on the controls to get the correct control for a CV. If we were to change the names on the controls, we'd break the stretchy spline. So that is worth pointing out for anyone who wasn't with us for the stretchy spline setup in the technical rigging series. So now if I grab my hips and I translate this down, you'll see that my bone is indeed stretching. Now we're only focusing currently on the first bone there and not on the rest, since they're not set up yet. But you can see we now go to our eye length or to that stretched length as we blend back and forth. So I'm going to set that hip control back to a value of 0, put it back in its rest position. And we can now go ahead and on all of our other bones, on bone 2, 3, 4 and 5, reference the bone length. Instead of having that length expression that we had already, we can simply go ahead and reference the length on spine underscore bone 1. That means we're going to have the exact same length as spine bone 1. I'm going to copy that expression and I'm going to paste that in for all of the other bones in our spine. Fantastic. So now when we are set to stretchy, you're going to see that our bones will stretch to meet these control objects. Notice even as I'm testing this, I'm undoing back to that rest position because I do want to have the rest position of these controls for the rest of the setup that we're creating for our spine. But you can see that we are indeed stretching, our bone lengths are changing. If we were to come down here and lock that stretchiness, I can come in here and work with the controls, but our bone lengths are never going to stretch. We're always going to maintain that initial length. But even when maintaining the initial length, because we are parented into the master control, we can come in here and uniform scale. Obviously our control objects are not going with us now because of the fact that we don't have them parented into any of the rig that's getting scaled, but you'll notice that our bone lengths indeed were still being scaled because of their parenting. So with that, we have now concluded the creation of the spine curve and also the bones of our spine. We'll continue setting up the spine over the next series of videos. Thanks a lot, everyone.